Now, in this particular question, we are going to be answering how to solve this 8 kilonewton force down, and this is a weird looking question, so think of this as like a lamp, not a lamp, like a pole sticking out of a wall, and you have like a support coming out at an angle. In the actual question, it shows that both of these are fixed joints. So when we start solving this question, and we've got to find all the reaction forces, the first thing we have to do is simplify the supports. We can't have two pin joints because that's 4 unknowns. We don't have enough equations to solve that. So we're going to assume one of them is a rolling support. So we'll assume that this over here down the bottom is the rolling support, and we're going to assume this is the fixed. Now this over here is different to other rolling supports we've seen previously because this one is in the vertical direction. So it can move up and down. Now let's identify these reaction forces. We have a reaction force going, let's say we're going to have a reaction force going to the right over here. We are going to have a reaction force going to the right over here, and we are going to have, this can do a reaction force going, it's probably going to go up realistically because that's going down. So we have our reaction forces. Oh, and if this over here is A, and I believe in our example this is D, so this can be reaction force A vertical, reaction force A horizontal, and this can be reaction force D horizontal. We don't have to simplify our loads, which is good. But we can go straight to point number 3, where we can say our sum of all forces vertical equals 0, forces horizontal equals 0, and moments equals 0. Now let's start by doing our sum of all moments about the pin joint, which is A. So sum of all moments about A, where clockwise equals equal to 0. We have, okay, so RAV and RAH don't exist because they're going to be times 0. The first force we have is this 8 kilonewtons over here. So we have, and it's going to be in the clockwise direction. So we're going to have positive 8 times 3. Then we have this force over here for the this D, where it's going to be minus, because it's going to be in the counterclockwise direction, reaction DH, and its distance is 1.5 times 1.5. So our RDH is going to equal 8 times 3 over 1.5. The maths is 8 times 3. It should just be 8 times 2, right? Yeah, 16. 16 kilonewtons. Cool. Now we can do our equations of sum of all forces in the vertical, where up is equals 0, up is positive. We have positive RAV, we have negative 8. So RAV is going to equal 8 kilonewtons. Alright, now let's do sum of all forces horizontal, where right is equal to right is positive equals 0. We have positive RAH, we have positive this of RDH, which as we've already said over here is 16, so plus 16. That's it. So RAH is going to equal minus 16 kilonewtons. What does this negative over here means? It means our original direction was incorrect. It is actually going in that direction. So it's actually going to be 16 kilonewtons going to that way. And so there are our 3 answers. We have RDH over here, RAV over here, and this is going up, yes, and this is also going, oh, this is going to the right. Right, that is our 3 directions for that, 3 reaction forces for that question.